Hi, good morning, everyone. So we are at TeepTalks, where industry leaders talk about performance. Good to have you, François, back.
Thank you.
Those who do not know me, I'm the CMO of TeepTrak, and we are with François Cloudon, CEO of TeepTrak and Zamba.
Thank you. Yeah.
So let's talk about the death of yesterday's data. Many factories still measure overall equipment effectiveness using manual spreadsheets compiled at the end of the shift or week. However, the modern standard is moving towards immediate visibility because an OEE matrix displayed right at the foot of a machine changes behavior in real time. My question to Francois is a lot of traditional plants are still essentially piloting their operations using yesterday's data, looking at spreadsheets roundup on Fridays to figure out why Monday was inefficient. In a market that moves faster, how much of competitive liability is to rely on lagging data? And what shifts when a team can see their efficiency metrics in real time?
Thank you, Ravinder. So I will try to answer this question with the two things. I think the first important thing is not necessarily if the data is from yesterday or the week before, and or instant. I think the information, depending on when you do the analysis, is going to bring different type of information. If you want to look at what happened the whole week or past week, you're going to have certain things that happen where you can react on a longer term, maybe actions that requires involving engineering, maintenance. And then, of course, you have this short-term information about a line being stopped or the problem with quality that will trigger very short-term actions to make sure that when we're producing, we can react quickly. The second point is when you measure this information, how good is the information? So technology is not only to bring back the information in an instant matter, it's also to make sure that the information is precise. So you were mentioning spreadsheets and paper and pen. It's good, right? But at some point, when you start to involve the human or the operators trying to understand when something happened, for what duration, you're losing a lot of information. So yes, the data, it's good when you have instant data. It's going to bring different things. Historical data for sure is good as long as both of these data are good.
My follow-up question to you is when a team moves from those end-of-week spreadsheets to real-time on-floor dashboards, what does this transaction day actually look like for the operators on the floor? Is there initial resistance from the operators?
No, I think, as I was mentioning, when the information is more instant, you're going to react on important things faster. But it doesn't mean that this is what we call that firefighting, right? So you have a problem, you need to react quickly. But not all problems are solved instantly. Some of them are recurring problems, some of them are longer-term problems. So you need both of these analyses. You need the long-term analysis, the historical analysis, and the instant information to make sure you react quickly. Do people tend to prefer a little bit of lag in the information? Probably it's a little bit more comfortable because if you make a mistake or there's something happening and it's right away everybody sees it, it's putting a bit more pressure. But at the same time, if it's done properly in a positive mindset, then the whole line is more productive, right? Okay. So I don't think it's only about it's like the change that it brings to the line is important, but it's also how you bring the change to the line that is important.
Okay. So my question is, when a measure asset breakdown, everyone noticed, but data shows in a real margin killers are actually hidden microstops. The tiny 2 minutes pauses, slight machine drifts that operator just gloss over. How can leadership begin to uncover these invisible losses? What kind of cash are companies leaving on the table by ignoring them?
Yes, Ravinder. So what you were mentioning is important, right? So you're going to have these two types of losses: longer term losses, more apparent losses, many minutes, many hours, and then you're going to have these small stoppages. If you don't have technology, it's way harder for the people to really understand how much they're losing on small stoppages. The way it used to work is, so there are many tools. One of them is what we call the tact board, meaning that we will try to understand how many parts we do hour by hour. And from that, we know a little bit what is the difference. And if we have big stops and then the number of part, we can see if we have a gap in terms of micro stoppages, right? We can do this analysis, but it's not very precise. And then this is where the technology does make sense, right? If you have a sensor or something measuring precisely if the line is working, not working, stop for a longer time or shorter time, then you start to have a perfect understanding on what is happening on the line. From there, sometimes it's going to be a lot of micro stoppages, sometimes not. And sometimes it's going to be long breakdowns, sometimes not. But at least you will have the information to conduct this analysis.
How do you help teams shift their culture so they can see these minor blips are worth solving?
Yeah, so going back to what I was saying, as soon as you have the information properly categorized, meaning you know how many small stoppages you have, how much time does that represent, how many big stoppages you have, how much time this does represent, and then you can do Pareto and then try to understand what's important, what's easy to fix, what is harder to fix. Then you can start to make priorities and then drive actions. And from there, this is how you make changes and impact as fast and as big as possible, because you put the resources at the right place.
Are there a unique advantage that smaller mid-sized manufacturer has over a massive conglomerate when it comes to deploying these agile IoT tools? Do they actually move faster?
It's a good question. I think large industrials need to be more careful, because what is at stake, especially for large factories, is way bigger and could have tremendous impact. I think about cybersecurity. I think about the way it's going to have impact on the people. So for sure, they have a bit more processes. They are going to have more ring fence to make sure that everything is safer, which make things slower. On the other end, I hope it's for something good for them, meaning that what is being deployed has less risk and is going to have more success. On the other end, as you were mentioning, when you start to work with smaller companies, they can react, decide, deploy way more quickly, sometimes with a different approach. And in this case, we are the safeguard, right? We are the person that I would say the company that is bringing the technology in a safe, secure, and impactful way. And we have no problem with that. With TeepTrak, we can bring this technology and make sure that it is safe, that it's going to work, and it's going to be cost effective.
So my next question is bridging the manufacturing skill gap. In terms of context, the manufacturing sector is facing severe labor shortage alongside a critical skill gap. As factory adopt advanced IoT systems, data analytics, collaborative robotics, the profile of floor worker is changing from pure manual labor to tech-driven system management. We talk a lot about upgrading our machine, but we also have to talk about upgrading human workflows. As our factory floors become increasingly digital, what is our strategy for upskilling our current workforce so they feel empowered by real-time data rather than intimidated?
Okay. To answer your question, what is a factory? A factory is going to be a place where you have machines, and these machines are going to be operated by people. Then you put raw material, and then you put energy, and it's going to produce something new that has, I hope, more value than at the beginning. When you describe a factory like that, you say you have people operating the factory, and the factory is changing, as you were mentioning. So a factory, I don't know, hundreds years ago, 50 years ago, 20 years ago, 10, 5, and now is changing. We have, as you were mentioning, more automation. We're going to have different technologies. And what the real shift, and this is what we call Industry 3.0, right? It's trying to bring more mechanical support to operators and replace what we would say simple task or lower added value task by machines instead of using humans. And technology, Industry 4.0 is a little bit in the same logic, where we're going to bring technology that is going to be a catalyst of all of that. Now, once we've said this, it means that the role of the people inside the factories is changing, and you need to train them. And this is directly linked to how many factories and how these factories are changing. if you look at how China is changing, it's crazy, right? The investment in factories, the number of robots per operator, number of robots per factory, the way they use the technology, electrification, they have an edge, right? So, and why they have an edge? Because their whole ecosystem is better. It's good because they have the right school, they have the right trainings for people. The overall level of education in China is crazy good. They have a lot of factories, meaning that they can train a lot of people. So you have a scale effect. You have scale effect for, of course, production. We see it, but also for everything that goes around production. You can make huge universities. You can make huge training centers. You can scale everything you produce. And this is important. What we see in Europe and also in America is that the overall age and number of robots per factory is going down. Probably it's a little bit because we're not investing as much in our factories, but it's probably because also it's hard to find the people to take care of the factories. If we look in France, we do have a problem with maintenance. A lot of people we lack maintenance for all the factories, and we also lack the people that knows the technologies to automate factories, connect factories. It's a very soft, I would say, skills, right? So being able to bring these new technologies inside factories. And the second thing is bring these technologies in a very efficient way, because it's easy to say, okay, I'm going to automate a factory, I'm going to connect a factory, but it's harder to do it than just to say it. So all in all, you're right. We need to work on the ecosystem that is going to support these factories. And this includes training the people that will work in the factory for now, but also for the future, because the factory will continue to change.
Modern industrial trends focus heavily on green manufacturing. Interestingly, maximizing machine efficiency and lowering scrap rates through process tracking has proven to be one of the fastest way for a factory to slash its carbon footprint and energy waste. My question is, sustainability is a massive corporate mandate now, but there's often a cynical view of going green just adds operational cost. Can you talk about intersection between lean manufacturing and environmental sustainability? How to optimize our machine efficiency directly translate into cutting resource waste and energy consumption?
Yes, I think producing in a cleaner way is important, and I think everybody agrees on that. But you must not forget that a factory is a cost center. So each and every factory in the world, except if they have huge margin and probably different, but the more you produce a commodity, the more you need to be cost effective. And cheaper energy is usually not as clean as, it's usually more expensive than clean energy. So what I would say is that producing in a cleaner way is sometimes a marketing gimmick, right? So you're not going to really produce in a cleaner way. Of course, if you produce in countries where energy is cleaner, you're going to have a lower footprint. But if these countries, the energy is more expensive, then the whole sustainability from an economic perspective of the factory is not as strong, right? So there's a balance. I think, and overall, when you think about it, if you look at the cost of CO2 and the cost of energy per part, it's very low. So it doesn't really make sense to try to be very clean or very competitive. So probably a lot of these factories, we try to make them cleaner, but I think it's more of a trend. China overall is shifting from coal to green energy. They have this huge plant where they make wind turbine, where they make hydroelectric dam, where nuclear. So this is going to change how all the factories around the countries are going to produce, right? And I think it's the right way of doing it. Factory by factory, unless your competitors have the same context and the same competitive environment, if you start to have way more expensive production costs because you try to go green, you will not go green for long. The source of energy is very important inside a factory, because if you use cleaner energy versus, I would say, more CO2 charged energy, you're going to have a different impact on the environment. But no matter the energy that you use, as soon as you start to produce, there's a way of using more efficiently this energy. And this is where OEE and where a lot of way of improving the processes can bring tremendous impact. I have a lot of examples where machines are either warm, heating, cooling. They have a lot of what I would say fixed cost from an energy perspective, where no matter what you produce, you're going to have to either keep cold or keep hot. And as soon as you start to maximize the way you use these machines, then your cost per part can go, cost in terms of energy and CO2 can go down drastically.
So, François, we are moving towards alert fatigue to contextual data. Early IoT deployments relied on threshold-based alerting. Ping me if machine exceeds 180 degrees Celsius. This caused severe alert fatigue, leading workers to ignore notification if they were spam. Modern systems combine automated machine data with operator context. The human tapping a table to explain why the machine is stopped to get a true story. My question here is, if you give a factory team a system that constantly buzzes and alerts team every time a machine blips, they eventually just tune it off. How do we design an operational environment that gives meaningful contextual data to our operators instead of throwing them in alert fatigue?
I think you're bringing a good point, Ravinder. So what I would say, it's the same way you build an action plan, right? You have a finite amount of, I would say, energy or resources to solve problems and improve things. When you start to have alarms inside factories where you expect people to react, if you have too many alarms, how do you make sure that the people react on the right things? So maybe, and I hope it's not the case, all the alarms that you have are very important. And I wish the people that are configuring these alarms that they did it properly. And then it's impossible to fulfill all of these alarms. Then you have another problem. But most of the time, as you were mentioning, sometimes the way it's the scale and the importance of each and every alarm is not necessarily clear for the people. So the way it works is that you need to have standards. And then the standards are going to frame how people react depending on what type of alarm. And from there, you will make sure that the way people behave is going to be well structured and always going to put efforts and energy on the right alarm types.
So if I understand, we have to build an intelligence, what alarms, what kind of beeps or alerts are important prior for human, where human has to come into, or what kind of alarms can be automated or we can ignore too.
Yeah. So the lean manufacturing has already defined these kind of behaviors, right? So you're going to have two things. The first one is going to be the well-known andons, what we call andons, which is going to be a visual management tool where if people need to react to something, they will see it. So most of the time it's a light, but andon could also be a sound, could be a lot of things that are going to trigger a reaction. And the second thing, which is not really 100% perfect, but I would say a pokayoke. A pokayoke is a tool where when what you're doing, it's going to make sure that you cannot do it differently, so you're not going to make a mistake. So there's a lot of good examples of pokayoke. For example, a SIM card in your phone, you cannot put it the wrong way around. But the pokayoke can also translate in a way where if you do something wrong with the machine, it's going to stop and give you an alarm. And so the way these things are built around the shop floor and what triggers an andon and what is going to stop the machine and give you an alarm are going to be the important things that you set up. And again, it's going to be a standard because you will program, you will code this in the machine, this in your processes, this with the tool that makes sure that the people do react according to the urgency and the importance of each and every matter they encounter during their day.
Industry trends shows a major pivot towards edge computing, processing the raw data directly on local factory devices. Flag anomalies and only sending the vital summary data to the clouds. There's a massive architectural shift happening right now that sends every piece of raw data to the cloud, moving instead towards edge computing, where the data is analyzed right on the machine. Why is keeping data processing local vital for real time decision making on a fast paced production line?
Yes, Ravinder. So I wouldn't say that cloud computing is more expensive than edge computing. I would say it's the other way around, right? So when you have a large machines, huge infrastructure, a small calculation is not going to have a huge impact on your cost. So doing the calculation on large servers is going to be more cost effective. However, what is very expensive is to send information. And a lot of signals are not easy to send. I'm going to give you an example, vibration, right? So vibration is a very good example because if you want to grab all the subtle things that can happen with vibration, you need to have a very high sampling rate, right? So really take all the dots that are going to make this information about what is happening either with an asset or whatever. And this is true also for voltage, current. So when you want to do fine analysis, you want to understand with a lot of information. And sending this information all the time from where it's measured to a larger computer is going to be a problem, especially if you have a lot of sensors inside a factory. So what happened is that you try to do, as you were mentioning, edge calculation with that information. So you bring just the right level of power at the physical place where the data is being captured. And you're going to try to send information that will sum up what is happening at that precise point, and that will allow you to react and do the proper analysis. Without being too technical, when you start to have like a signal, the best calculation to transform this signal is going to what we call the Fourier transformation, right? Where we're going to say, okay, this signal is a mix of these frequencies with these amplitudes, and with that information you can track if the way you this construct the signal to get these amplitude and these frequency is this is where you do the analysis. So instead of sending hundred or thousands or tens of thousands of points, you will send these 5 information, and you will be able to nearly understand that, though depending on the type of signal you have, but I would say close to 100% what is happening on the edge.
How feasible is it to deploy edge computing at the client today?
So after, because the technology is now very mature, because we have a lot of protocols to send the information. You have Wi-Fi, you have what we call LoRa, and you're going to have Bluetooth, which is also a very good protocol. The technology is not a problem anymore. It's more about where you want to grab the information and why you want to grab that information. Because at the end, what is important is not to forget that you want to drive actions. You want to make action plans to improve. So what information do you need to, as I was mentioning, focus your energy on the most impactful actions and where you need to focus your efforts?
Okay. I have a follow-up question here. Does moving towards edge computing mean we are saying goodbye to cloud computing, cloud entirely? Or is it future more of a hybrid model where the edge and the cloud play different and specialized roles?
No, I think, as I was mentioning, it depends on the type of transformation you want to do. So edge computing is good for a few things. As soon as you want to have, I would say, larger or more complex models, it could be AI, it could be algorithms, it could be a large set of data, then cloud computing makes a lot of sense, right? In our case, at TeepTrak, we're going to have 3 levels, right? We're going to have where the data is being captured. So we have these modules where we bring it to the machine. Low level of transformation, we're just capturing the information, we're sending it to our user interface. From there, we're going to conduct proper analysis of the information we're going to receive. So you have this kind of already starting to have this kind of edge calculation where we try to have pulse and very detailed information transform into what we would call perf log. So understanding what a machine is doing from that moment to that moment. So it's already reducing by a lot the amount of information without losing any depth or understanding, right? And from there, we send the information to the server where we're going to have reports, where we're going to have dashboards. So these kind of calculation and analysis that are going to bring visuals are going to be done over a year, that are going to be done frequently, requires strong calculation, more disk space. Then this is where cloud does make sense.
So my last question is about AI beyond its hype. While the world is hyper-focused on large language models, a true power of AI in manufacturing lies in specialized machine learning algorithm natively embedded into IoT platforms to map out normal machine behaviors and predict structural failure before they happen. Every corporate boardroom wants to talk about artificial intelligence right now, but a lot of it isn't just marketing hype. When you look past the buzzwords and flashy headlines, where do you see specialized machine learning making a significant bottom line differences? How does it actually improve and boost our factory floors today? I would like to know more about Zambatu in this case.
So Ravinder, thank you for your question. I think when we start to talk about AI, because it's new and because not everyone is at the same level of understanding of what AI can do, people are a little bit misunderstanding what is AI. For a lot of people, AI is mostly LLMs, right? So language models where you ask questions, you ask for a task being executed, you ask for support writing code. So these are like a subpart of what AI can do. AI can be something else than LLMs, right? So it can be, for example, machine learning, where you're going to analyze the information that you get from anything, could just a time series, and try to get insights out of that. When you look at what is good for the industry, it depends what you want to do, and then you will choose the right AI technology to get insights and better understand what's happening on the shop floor. If you are recording, as I was mentioning, vibration, temperature, current, voltage, lots of physical things that are happening on the line, then you want to use machine learning, right? You want to understand, so can I predict what is going to happen? Can I recognize if there's a problem happening right now? Can I optimize what's happening? So if I, for example, have an output in terms of quality, and then I have all the settings, then this is what is going to, you want to understand how these settings are going to impact quality. And then for any reason, one of these settings is, I don't know, machine speed, machine temperature. You want to make sure that you're putting it at the best place to maximize your quality. And this is what Gemba is doing, right? On the other end, LLMs also have their fair share of value, right? I have a lot of data regarding a set of machines. I would like to get OEE information from last week and try to understand, depending on all the stoppages, what I should do. Then this is where language models would make sense. We have one which is the chatbot, AI chatbot in TeepTrak.net, where you can start to ask questions and then explain the type of stoppages that you have, or the chatbot will soon be able to directly go see your information and then make recommendation on what kind of action you should drive, in which order, and what kind of impact you will do. So AI has a broad scope of things that can happen. Of course, Gemba can do a lot of things, but also TeepTrak with the classic tools can bring more value than just pure basic analysis.
Just adding a question here. How many operational floor managers who are interested today for AI to adopt AI, do they asking the right questions today? Because you said it's not about challenging operational people or operational factory people. Are they in capacity today to ask right question?
So Ravinder, if I understand correctly, what you're saying is, first, do people understand all the benefits that can bring AI? And two, are they afraid of AI because they don't really understand or lack resources that are a bit more specialized in AI to support them or on their day-to-day problems? And the answer is probably inside factories, you have so many potential, so many bucket of value everywhere related to deeper analysis that could be done with AI, but a limited amount of data scientists and the expert people that can really understand this value and give it back to you or make it available, right? So what is happening today is that you are going to have some type of production lines and some types of factories that are going to produce very expensive stuff or something that if you have minor changes, it's going to bring tremendous value. And you have oil and gas, for example, all the refineries. You're going to have pharma when you start to make meds, where if you make it wrong or if you optimize it a bit, you are going to have a tremendous impact. And so today, solutions do exist for this. Either you take data scientists that are going to be expensive, or you take expensive solutions. There are a lot of expensive solutions that are going to be 50, 60K per year per factories, right, in terms of recurring revenue, but that are going to bring a positive ROI. Now, all the rest, small value everywhere with probably not a very good trade-off or a very good ROI if you take the expensive solution to solve that small problems, right? There's a lot of things around this. So for sure there's a real potential to bring a platform where people can put their small problems in and get a solution out without having to involve expert people. And this is a little bit what we're trying to do with Gemba. The same way people use ChatGPT or Claude to, on a very small daily task, get support, then we can bring the same with Gemba into each and every factories, where you start to have minor problems with data that you would like to get solved, then no problem, we can do it.
So to conclude our podcast, it's exciting to see how cutting through the corporate noise, there are practical tools that are actually keeping plants competitive. François, thank you for breaking down how physical and digital floors are finally speaking the language today. It was great having you at TeepTalks. Stay tuned for our next episode.
Thank you, Ravinder.